Okay, fine. Then we'll start with the new topic. So in our previous class, we saw that there are three technology that can be implemented in our network, right? So we have already seen the Ethernet network technology, and then we are yet to see the other two, that is token ring network technology and FDI, which stands for fiber distributed data interface network technology. So let us look at the first one, token ring network technology. In fact, we have already come across briefly in our previous class, right? Okay. So there are other network implementation that you might encounter, one of which is token ring, okay? So many ring topology are based on the token ring technology. So we have seen that Ethernet is mostly the topology for Ethernet network technology is bus, right? Bus topology, and most of the ring topology, okay? So ring topology, many ring topology, most of the ring topology implements they are based on the ring token ring technology. Okay, let us see why, how it is token ring. Okay, so initially token ring technology was opted where contention based networking Ethernet was deemed unacceptable. Okay, so at the early stage when the network was just introduced, okay, in the world, Ethernet was Ethernet caused lots of problem. Okay, the network performance was not good in terms of Ethernet, okay, technology. We have seen that in the earlier stage Ethernet, right, it uses the there were no bridges or switches implemented, right? So thereby it caused loss of collision, right? And then the transferring of data was problematic in terms of Ethernet technology, right? And then we saw how Ethernet has evolved from bridge Ethernet to switch Ethernet, right? So in early time, okay, when the Ethernet could not process, okay, the network performance was not good in terms of Ethernet technology. So that time, initially token ring technology was opted rather than Ethernet. So most people went for ring topology, token ring topology. Okay, not topology, technology. Token ring technology was chosen. Okay. But okay, with today Ethernet has surpassed token ring network in popularity. So we know that, okay, by evolving from bridge Ethernet to switch Ethernet, the Ethernet technology has become much faster, okay, compared to ring topology. Then, okay, rather than ring topology, now people opt for Ethernet topology. Now Ethernet has been much more popular. Okay, the network performance has increased, the transfer rate has been increased, so everything is much better, okay, in terms of compared to the ring topology. Today, if you were to encounter a token ring network in the workplace, it is unlikely that it will be in the new land. Now, in current scenario, okay, you won't find token ring technology or token ring network, okay, token ring technology implemented in the network. So if you encounter any, then that would be the legacy, the older one, that okay, the organization may not have been able to shift from token ring to Ethernet due to some problem. So that time they might have used the same token ring network, okay, rather than Ethernet. So if you see any network with token ring technology, then that would be the older one, okay, not the new one. Any new network, okay, that are designed will implement Ethernet, not token ring, okay, or other network topology, technology. So token ring networks still exist in legacy implementation, and so it's important to be familiar with the technology, not only for maintenance reason. So okay, if you are the IT person, okay, network administrator who has to work with the organization that has implemented the token ring network, then you may have to understand how does it work, okay. And then also for the maintenance reason, if there's any problem, then how you should go about, what are the things that you have to consider, okay. So let us understand how, okay, the media is being accessed by the devices in the token ring network, okay. So token-based media access method is used by token ring technology. Okay, so token-based media access is a media access method in which computer passes a spatial sequence of bit called as token between them. So in fact, we have already we have seen this one in token ring, how the data is transferred, right? So in token ring, okay, the media or the cable, okay, or the transmission medium are accessed, okay, through a method called token-based media access, which is a special sequence of bit called as token. So this token is passed around in order to transfer the data. Only the node holding the token can transmit on the network. So the condition is that any node that holds the token can transmit the data in the network. So it's similar to you waiting in a line, right? Maybe, for example, in hospital, for example. So you have a token. So whenever your token number comes, then you will be able to access the doctors. There are services provided by doctors, right? So similarly, okay. So this token, whichever device has the token, will be able to transmit the data or use this transmission medium for transferring the data. So after transmitting its data, or if it has no data to transmit, the node passes the token to the next computer on the network. So if whenever the device receives the token, okay, if it has data to transfer, then it will transfer it whenever it receives the token. If not, then it will pass on to if not, it will pass on to the other system, whoever has to transmit the data. So the token will be passed around, okay. The standard dictates how long a node can hold the token and what happens if the token is damaged or lost. So token ring topology technology also defines the standard, okay, that each device, how long each device can hold the token, okay. And then when if the token is damaged or if it is lost, then what happens? What are the things that has to be considered? So this all of this informations, okay, standard are defined in the token ring technology standard, okay. So let us look at some of this standard, token ring standard, okay. So there are two token ring standard that are very similar, okay. There are two organizations that has defined this standard for the token ring technology, okay. So any network that have implemented the token ring, okay, topology, then this standard has to be followed, okay. So IBM and IEEE have defined the token ring standard, okay. IBM is called as IBM Token Ring and it was introduced in 1970s, and IEEE standard is called at 802.5 and it was defined in 1980s. So if you all remember in our last class, we saw that 802 dot X was a family, right? From where a subcategory we had 802.3, then 802.2, right? 802.3 and 2.2 was for Ethernet, that standard defined for the Ethernet technology. Then 802.5 is, okay, this standard defines, okay, regarding the token ring. So all the standard that are for the token ring, okay, technology is all defined in this IEEE 802.5, okay. So there's a brief comparison between the IBM token ring and IEEE 802.5 token ring standard, okay. So both, okay, IBM and IEEE says that the transmission speed should be 4 Mbps or 16 Mbps. Then topology, physical topology, both in IBM it is specified as star, IEEE is not specified, okay. Then in each topology, okay, number of node per ring in each ring, okay, the IBM has specified that if you are using the cable, STP cable, then you can have 260 node, and if you are using UTP cable, then you can have 272 node, okay. Whereas IEEE, the device, the cable has not specified, it has just specified the number of node, that is 250. So you can have 250 node connected to a ring, okay, not more than that. Then media type in IBM, STP, UTP, okay, of category 1, 2, 3 are specified. In IEEE, it is not specified. Then signaling, both baseband, okay. Access method, again both same, token passing, so token is passed around in order to access the media. And encoding, both uses differential Manchester encoding, okay. So this is a comparison between IEEE and IBM Token Ring standard. Okay. So it also state, okay, the standard also state, okay, the token can be in this state, one of these following state, okay. The token can be available, okay, the token state might say available, captured, acknowledged, or reserved, where available means, okay, as of now, in token there is no data, so you can think the token as maybe say, let's say for example a taxi, okay, where there is no passenger, right? So you can have a passenger, you can think passenger as a data, actual data, okay. But do not write this in example. If you write this in exam, okay, if you say the token is like a taxi, I'll give you a big zero. I'm just giving this example so that you all can understand, okay, just comparing it, but do not give this example in the exam, okay. So if the state is available, that means there are no data in the payload, okay, so that you can now use this, okay, capture this one, okay, token, and then send the data. Then as soon as some device has captured, okay, the token, okay, to send the data, then the state will change to be captured. So if, okay, the node sees that the token state is captured, then it is understood that there is some data in the token, okay, somebody has captured the token. So all node that receive the capture token evaluate the destination address to determine if the data has reached its destination or need to be passed again. So any device that receives the token, okay, with the state capture will check, okay, am I the destination, right? That means I'll have to check the data, right? If I'm not the destination, then the token will be passed on to the next device, okay. Then another stage is called acknowledge, okay. Notification, either positive acknowledgement or negative acknowledgement sent from the receiving node to the sending node once token reaches its destination, okay. Acknowledge indicates good data, negative acknowledge indicates bad data, okay. So that means so let's say for example the device has received the captured data, right? Then it will acknowledge back the, okay, after taking the data, okay, the token will now change its state to acknowledge. Thereby, the receiving device will acknowledge back with positive or negative. Okay, positive indicates that the data is correct. There is no any error in the data, whereas negative says that there is some problem with the data. Okay, so accordingly, it will send the acknowledgement through token, okay, where the state would be, token state would be acknowledged. Then the last one is reserved. So priority system used by both IBM and 802.5 IEEE, okay, token ring, in which the token can be reserved. So token, if somebody is, okay, has captured, okay, or has been acknowledging, okay, the token is in use as of now, okay, then what you can do is, if you have if that particular device has data to send, then it can reserve that token, okay. So token, if more than one device reserves the token, okay, you can set the priority. Okay, a priority, based on the priority, the token will be delivered to that particular device. The most higher priority is considered as emergency. Okay, so the device with higher priority will be given the chance to transfer the data. The token ring network uses a sophisticated priority system that permits certain user-designated higher priority stations to use the network more frequently. The token ring frame have two fields that control priority, okay, the priority field and reservation field. Okay. So token ring will have two fields: priority field to indicate, okay, that the priority number, and reservation field by which device. Okay, so if the priority, higher priority, will be given the token to transfer the data. So only station with priority equal to or higher than the priority value contained the token can seize that token. Okay, so for example, so let us consider, let's say for example, initially the token, okay, when token is being passed to this system, okay, it is in available state. That means there are no data. The token is free as of now. There is no data that is being transmitted. So as soon as this device, okay, receives the token, okay, so this device has, let's say, some data to transfer to this system, okay. So what it does is it will capture the token and then send the data. Now the state of the token would be captured, and then this one would be, the token will be forwarded to this system. The system sees, okay, that the state of the token is captured. It will check whether the token is destined for the system itself. If not, it will pass the token to next device. Then again, this device will check, okay, it will see that the token is captured. It will check whether the data is for the device itself, okay. If it is for this particular device, it will receive the data. If not, it will pass. Since the data is for this particular device, right, it will acknowledge either positive or negative. So as soon as it acknowledges, the state of token will change to acknowledge, and then passing to next device. So this next device, okay, checks the state, and then it also has some data to send. Okay, so it will check the state. So it says that the state is acknowledged. That means it has to be delivered to some device, next device, right? So okay, so this device wants to send data. So what it will do is it will reserve, okay, reserve the data with priority, some priority. Okay, now the state will change to reserve, and then it will forward to this device. So this device will check the token where the acknowledgement can be either positive or negative, and then this is that the device is now reserved, right? And then forward it. Okay, and then until it reaches here, okay, if there is no other device that has reserved, okay, if it has reserved, then it will check the priority. Whoever has the higher priority will receive the token, okay. And then finally, when the token reaches here, the token will now be used to send the data, and then the token state will change to captured. Okay, so that's how the data is being transmitted in the ring topology. So IBM Token Ring network uses stations are directly connected to multi-station access unit, MSAUS. So we have already seen that one in, I think, unit 1. So this multi-station access unit, okay, it acts as a central device that controls the access of the media. So IBM, okay, IBM Token Ring, it uses the standard device called as MSAU, okay, which are wired together to form one large ring using the patch cable and lobe cable for the connection. So what it does is it will, okay, pass the token, okay, around. So let's say, for example, this device wants to connect with this device, okay, communicate with this device. So what it will do, it will send the token to this one, okay, then this will pass here and then pass here, and then pass here, and then go on in the ring. Okay, where this one MASU, it helps in sending the data in the in ring topology. Okay. So it will pass around the signal, pass the signal around. Let us look at the functionality of MSAU. MSAUs also include bypass relay for removing node from the rings. Not only passing the signal, okay, the other usage, okay, use of this MSAU is to bypass the relay for removing node. If there is any node that is being removed or dysfunctional. So MSAU is responsible for connecting the ring in and the ring out connection from each client to its neighbor, responsible for jumping around any disconnected client for continuing the ring. Okay, so for example, let's say in this ring topology, so in the actual scenario, what happened is in the ring topology, right? This device will pass the token to this one, then this one, and this one, and then it will continue in ring, right? So what happens if this device, okay, is not functioning, okay, or is not online? There's some problem with this device. Then the flow of this ring will be disconnected. So once this device sends to this device, then this device sends to device, then this device won't be able to send to the next device. So there won't be the continuity. The network, okay, will be the network won't function if there is a problem with any device in the ring topology. Okay, so because of that one, you have MSAU, okay, which will bypass. Now, okay, this device sends to MSU, okay, MSU forward to this device, okay, then this device again forward to MSU, forward to this device. So it sees that this is not functioning, so it will bypass. Instead of sending to this device, it will directly forward to next device. Okay. So token ring failure recovery. Okay, if there is any problem in token ring, how it is recovered. The token ring network take on star configuration when a device is turned off or disconnected from the network. In this situation, MSAU simply bypass the disconnected device. So when a device is online but unresponsive, the MSU keeps the connection live but breaks the ring because the device is not passing the data. Okay, so that is the function how token ring, okay, failure are recovered. It is help, okay, the recovery is done through the MSAU. Okay, until this device is working, okay, MSU will bypass it. So as soon as this device is working, then the normal flow, okay, the ring topology will be normal, then the flow would be normal. Okay, so MSAU plays a major role in token ring failure recovery. Okay, so that's that is one reason. Another is token ring beaconing. Okay, so there is a process called beaconing, which is, okay, used to ensure that all systems on a ring are responsive. With the help of this, okay, process called beaconing, it ensures that all the devices in the network in the ring topology are responsive, alive, working. Okay, so when a ring is established, each device sends a beacon every 7 seconds. Okay, if the station does not get a beacon signal from its neighbor, it notifies that the network that the node is down. Okay, so what happens is every 7 seconds, okay, beaconing is sent. Okay, a beacon is sent. So this device will send a beacon to this device to its immediate, okay, to this one and this one. Okay, similarly, this device will send a beacon to this system and this system. Similarly, this device will send to its immediate, okay, beacon to this system and this system. And similarly, this device is also supposed to send, okay, to this system and this system every 7 seconds. Okay, so Okay, the device, okay, for example, this device and this device does not receive the beacon from this device after 7 seconds, right? So it is understood that, okay, there is some problem with this device, okay? So that's how the fault in the network, okay, is identified in token ring. So as a result, okay, a traffic is reconfigured. So in this way, how, okay, in this way, a result, okay, in this way, the traffic is reconfigured to loop back around the failed node. So as soon as, okay, there is, okay, with the help of beacon, the device, okay, the device that is not functioning, or the device that is down is no identified, then the loop is now, instead of okay, sending to this data, the data will be sent to this one and then reconfigured. Okay, the loop will be reconfigured. So let's say, for example, this device will forward to this device and this device, and then we know that this device is not working right, and it will be forwarded back to this device and this device, thereby trying to create the ring in the topology. Okay. Okay. So this is regarding the token ring topology. So do you have any doubt regarding token ring topology?